You know, CT scans give us this absolutely incredible window into the human body. I mean, they're one of the most powerful tools a doctor has, but they're not perfect. Sometimes these super complex images have these strange imperfections, these visual glitches. You might even call them ghosts in the machine. And these can actually hide what doctors are trying to see. They're called artifacts. And today, we are going to pull back the curtain and see exactly what they are and where they come from. So here's our game plan. First, we'll nail down what a CT artifact actually is. Then, we'll dive into the main culprits, glitches caused by the laws of physics themselves, then the patient factor, then errors from the scanner, and finally, we'll look at some of the weird new challenges that pop up with cutting-edge scanning tech.
All right, first things first, let's really get to the heart of the problem here. We're on a quest for the perfect picture of our insides, so why aren't these images always crystal clear?
And that's really the million-dollar question, isn't it? A CT scanner isn't just a camera snapping a picture. It's an incredibly complex machine that's rebuilding an image from, literally, millions of tiny measurements. And in a process that complicated, well, there are a lot of places where things can go a little sideways.
Okay, take a look at this. This is a scan of a spine with metal implants. See all those bright streaks exploding outwards? Yeah, that's not supposed to be there. Those are artifacts. And they are so bad here, they could totally hide what a doctor needs to see, which pretty much makes the scan useless. This is the problem we're talking about.
So let's get technical for just a second. What is an artifact? I know this definition looks a little dense, but the idea is actually pretty simple. The scanner basically measures how much an X-ray beam gets weakened or attenuated when it passes through you. An artifact is just any part of the final picture that doesn't match up with that true value. It's a glitch in the matrix, a mismatch between what the machine saw and what was actually there. And here's the interesting part. These errors aren't just random. They actually fall into four main categories, which gives us a great way to understand them. You've got artifacts that come from the laws of physics, some caused by the patient, others by the scanner itself, and even some that are side effects of the super advanced techniques we use today.
So let's kick things off with the big one, maybe the most fundamental cause of all: physics-based artifacts. These happen simply because of the way X-rays and matter interact with each other. You just can't get around it.
And the number one offender here is something called beam hardening. Think about it like this. The X-ray beam that a scanner shoots isn't just one energy level. It's a whole mix of them. As that beam travels through your body, the weaker, softer X-rays get soaked up first. That leaves behind a beam with a higher average energy, a harder beam. And that change can really mess with the scanner's final calculations.
And here's what it looks like in the wild. When that beam has to pass through really dense stuff like bone, it gets hardened unevenly. The result? You get these weird dark bands or streaks, often appearing between two dense objects. You can see it plain as day in this chest scan right here.
But here's the really cool part. We aren't just at the mercy of physics. Engineers have come up with some incredibly clever ways to fight back. They use special filters, some are even shaped like a bow tie, plus really sophisticated software and precise calibration. Even a good technologist can help just by positioning the patient in a way that minimizes the effect.
And the proof is in the pudding. I mean, look at this. On the left, you've got that classic dark banding artifact in a skull scan. But check out the image on the right. After the correction software works its magic, the image is so much cleaner, so much more uniform. The difference is just night and day.
Okay, so we've seen how physics can throw a wrench in the works. But the next big source of these artifacts doesn't come from the machine or the universe at all. It actually comes from the patient. Yeah, us. It really boils down to two key things. First, metal. Stuff like surgical implants, dental work, pacemakers. They're so incredibly dense, they just completely overwhelm the scanner and cause those wild streaks we saw earlier. And second, just plain old moving. If you move at all during the scan, even just breathing or your heart beating, it's like trying to take a photograph in the dark with a really slow shutter speed. You just get a big blur. But just like with beam hardening, the software wizards have come to their rescue. Remember that crazy image on the left? Well, look at the right. This is after a specialized metal artifact reduction program has been run. It's not totally perfect, but the improvement is absolutely incredible. It goes from unusable to diagnostic. And it's the same story for motion. On the left is the blurry image you get when the patient moves around. But on the right, after some smart motion correction algorithms do their thing, the edges of the organs are so much sharper, way more defined.
It's this amazing combo of good technique, like having the patient hold their breath, and this really advanced software working together. Okay, so we've blamed physics and we've blamed the patient. But what happens when the machine itself is the one to blame?
This right here is a classic. It's called a ring artifact. See, a CT scanner has literally thousands of tiny detectors that capture the X-rays. If just one of those detectors is off, even by a little bit, it gives a consistently wrong reading every single time it spins around. And when the computer puts the image together, that one tiny error creates these perfect, ghostly circles. Now, the good news is, unlike fighting the laws of physics, the fix for this is, well, pretty straightforward. You have a broken part, so you either recalibrate it or you repair it. It all comes down to good old-fashioned maintenance and quality control to keep these amazing machines running perfectly.
And that brings us to our last category. And this one's a bit ironic, because sometimes the very technology that makes scanners so fast and powerful today can create its own brand new types of artifacts that just didn't exist before. I mean, just look at this weird pattern. They call it a windmill artifact, and you can totally see why. This is something you'd only see on a modern multi-section scanner. It's basically a side effect of the incredibly complex way that all those multiple rows of detectors capture data during a super fast scan. It's a glitch born from progress. Here's another one that was a bigger deal on slightly older machines. When scanners used to take thicker slices of the body, the final 3D image could end up with these jagged edges, kind of like a staircase. But as you can see on the right, this is a problem we've pretty much solved now by using modern scanners that take incredibly thin, overlapping slices. The result is just so much smoother and more accurate. So what's the big takeaway from all this? I think it's that when you see a really clean, crisp CT scan, you should realize what an amazing technological achievement it is. It's not a given. It's the result of a constant battle being won on all fronts, against physics, against biology, and even against the quirks of our own technology. And that kind of leads to one final big question. We've seen just how far we've come in fighting back against all these different glitches. As our scanners get even faster and the software gets even smarter, it really makes you wonder, will we ever get to a point where we can eliminate them all? Is the perfect, totally artifact-free image even possible? Or